Hi everyone. Hope everyone is enjoying their code days off. I know I'm pretty late with this video now, so I apologize for that. Today I am going to talk about what you will need to know to complete the predator and prey exercise that you guys are going to be working on this week. It is probably our last dedicated GridWorld project. After we finish this and we go over the solution, we'll jump into um, back into Big Java and talk about array lists and arrays and mess with that a little bit more. And every so often, we'll inject a critter project so that you guys don't forget everything. So I'm going to let you guys read over Predator and Prey on your own. It's already on your Google Drive. You can hit pause if you want, or you can read it over in class. But in order to complete Predator and Prey, we are going to talk about how to detect actors that are two locations away from the critter. So that's going to be our focus today. Hopefully, it won't take about 10 minutes, so that the video is not too long. But let's take a look at our code. So here on our right side, we have a detector class. Um, I am probably not going to put this detector class online, but I'll leave it on the video. You guys can look at the video and copy the code off of it if you want. Um, you know, but you know, just to have you at least go through the code instead of just downloading. At least this way, you'll type it out and um, you know get to learn it that way if your group needs to. So our detector class here extends critter. Something you may have noticed is the resolution. It's super high. I figured since I'm using Camtasia now, I'm gonna pan in and out with Camtasia. So I decided to use my desktop, which is at a much higher resolution. So detector extends critter. I've got my default constructor, and then I've overloaded two methods. The first method I overloaded was get actors, and the second method I overloaded was process actors. Now, the reasons why I chose get actors and process actors is because get actors' job is to retrieve all the actors that are going to be processed by this critter. And as you all know, critter is all about learning which methods you need to overload and how to modify each method's behavior to fit whatever new critter you're creating. And with predator and prey, they both are able to not just see their immediate neighbors, but to see two locations out. So today we're going to look at the code that will do that. Um, so here our first section is something you should already be familiar with. Grid actor grid is assigned get grid, and we're checking to see if it's null. You've seen this before in bug. You've seen this before in critter. It's all about knowing whether or not your critter is in the grid, and if it's not in the grid, we should end the method immediately. All right. So let me scroll down here. Our next two segments of code, or let's go to the first one. The first thing I do is create an array list. It's called actors. It is assigned a new array list object, so it's going to be an array list with no objects in it. The purpose of the actors array list is to store all the array lists. I'm sorry, is to store all the actors that I intend to return. The next variable I create is my location. It's just I created that variable just so that I don't have to call this method over and over and over again. It makes for easier typing. Before I get into the next part, I want you to keep in mind that this is not the only way to figure out all your actors that are within two locations. However, the last couple of years, students have preferred this method over the other one that I've used before. So this year, I'm just going to start with this one and probably not go into the other way of doing this too much. So before we look at this segment of code, let's go back and take a look at visually take a look at what it means to look at two actors within, or look for actors within two locations. So here we have, let me grab a pen here. Here we have a grid that I drew up, and the red dot here in the center. All right, let me circle it. Our red dot here in the center is the critter, and what the purpose of, or what get actors should do is find all the actors that are not just in the immediate neighbors zone, our green zone here, but also include the actors out here. Right, so we're looking at possibly a lot more actors. Instead of, was this 8 actors, there could be a total, I think, like 24 or 25 actors. I think it's 24. So in order to do that, we're going to treat we're going to treat these 2 locations out. We're going to treat it as a grid. And if you guys think back to Drunken Walk or Drunken, I forgot what that project is called. Drunken Walk, I think it was, where our drunk would, where we had to draw a grid and it kind of went, our for loop kind of drew the grid like this. We're going to do that here. So instead of just asking using the, what is that method called? Get neighbors, I think, I think it's called get neighbors. Instead of just using that method and treating the immediate ones, we're going to start in this top left location and we're going to check this way, right? We're going to look at every location going in that direction, and then once we've checked every location going in this direction, we're going to move to the next line and we're going to check everyone going in that direction, and we're going to check it every location going in that direction, and we're going to keep doing this and looking at every single location until we're done. Right? So again, if you think back to how we drew the grid before, what we're essentially doing is for each row, so this would be row 0, row 1, row 2, row 3, row 4. For each row, we're going to look at each column. So it's column 0, column 1, column 2, column 3, and column 4. So when we first start, we're looking at row 0, column 0, right? We're going to look at that location. Then we'll move to row 0, column 1. And as our column climbs, there's repetition here, right? Our column is slowly increasing by 1. And then once we're done with column 4, row 0, we then go to the next row, and column starts at 0 again, right? That was the pattern of our nested loop that we used before. So let's come back over here to our right side here, and we're back to seeing the same loop, right? So I am going to come into, and I wish I had prepared this earlier, and it's my own bad preparation here. I'm going to screen clip this so that I can draw on it. All right, so we'll come back over here, and we'll zoom in with Camtasia. All right. So I have my nested loop again here, and notice that the initialization of row is not just a simple 0. Instead, it's my location dot get row. So my current location, the row value for my current location, and I'm going to subtract 2 from it. And if I come back up to my drawing here, if this is my location, my location dot get row would return the value 2. And the value 2 here, let me circle the value 2 because that's the row I'm in. So I'm going to say subtract 2, so 2 minus 2 is 0. So it brings me up to this row. And then for the column, you can see that my column initialization is my column, or my location that get column minus 2. So that takes us to 0, 0. So what my nested loop here is going to do, let me undo these underlines. My nested loop here can do is, for my row, I'm going to start at 0, and for my my condition here as to when I should stop, I'm going to say my current row plus 2, right? Because we want to be 2 out, and we can very quickly scale this these nested for loops to be 3 locations out or 4 locations out just by changing some of the values. And I realize these 2's here are kind of magic numbers, and I apologize for that. But yesterday when I was making this, it didn't occur to me to make them constants. So we have a very familiar nested for loop. The only thing that's changed is the starting values for row and column and the ending values for row and column. Right? So instead of saying 0 and length for size or whatever it is we did before, we're now using our current locations, get row and get column, and figuring out from there where it should start and end. Hopefully that makes sense to you. So inside of our body of our for loop, what we're going to do is always take that current row and column and we're going to create a new location out of it. And when we have our new location, once we have our new location object, we're going to take that object and check to see if it's valid. Right? We want to know if that location is in the grid in case my critter is up against a border or it's close to a border, and two locations out mean it's looking off the grid. So we're going to check to see if it's valid. And if my location is valid, then I'm going to try to retrieve an actor at that location, which is what the get method does, right? So the get method is going to retrieve the actor at that location, and if you check the documentation, what it'll tell you is that it'll try to retrieve an actor, and if there is an actor, obviously it'll return that object, and we can assign it to my variable here. But if there is no actor, what's going to happen is that it's going to return the value null. So it's going to return an object or null. And if it returns null, it means that there is no actor there. So the next thing I need to do is, I need to check to see if that variable has an actor or if it's null. So the condition here says if it's not null and my current actor is not equal to this, all right, I'll give you a moment to think about what that means. Right? If the variable's value, current actor, is not equal to this being the calling object. Right? Have you figured it out? In other words, we're checking to see if the current actor that was retrieved is equal to the calling object. Right? If I scroll back up here, remember our pattern takes us through every single location going from left to right, including the location that my critter is at. So what we want to do, right? What we want to do is not include my calling object inside of the list that's going to be returned, because obviously the detector critter is not a neighbor of itself. All right. So if I come back down here, if both of these conditions are satisfied, if current actor and not current actor dot equals this, if both conditions are true, then I can add that or actor to my list. And if I come back over to BlueJ, what happens is once we're done with that nested for loop, I can return my list of actors. Now, if I take a look at process actors down here, I changed process actors up a little bit. The only thing process actors does is print to the terminal window a list of actors. There are easier ways to check to see if get actors worked, and I'll show it to you. But I figured since we're talking about critter and this is detector critter, all detector critter does is print to the terminal window who's around it 2 locations out. Right. So we have an enhanced for loop that checks for every actor. For every actor in my list, which is coming in as a parameter, I'm going to just take that actor and send it to the terminal window. And the actor class does override the toString method, and the toString method prints out the information for actor. And you'll see it in a moment. And the other thing that I also do is print the number of actors to the terminal window, so that I know if the number is correct. So at this point, let's open BlueJ here, and I am going to run it. Right. So I have a driver. So we have our nice little GridWorld here, and what's in my driver is a little code that I wrote up. Right. So here's actor world. Hopefully some of you figured this out on your own by now. When I create a new actor world, I can actually create any size grid I want, some new bounded grid of actors. I'm going to say 5, 5, to kind of mirror the drawing that I gave to you earlier. And we're going to add our detector at the very center of my grid world. And then I create a little nested for loop here again that goes from 0 to 5, 0 to 5. And what that's going to do is, if my row and column, if they're not equal to 2, in other words, if it's not the center, I'm going to add a new flower. And if I kind of come back out here, that's what that loop does. We create this kind of, it creates this grid world full of flowers with my detector critter in the middle. As you can see, my detector critter is the capital D. So now if I click on the step button, we're not going to be able to click on the run button because we really don't want it to run continuously. If I click on the step button, what's going to happen is the act method for critter is called, and as you know, um, the act method in critter is going to call get actors, then it's going to call process actors. So I'm going to click on step, and there's my terminal window the um, with all the critters in the array list that's being printed out. So you can see that they're all flower objects. There's the location, direction, and color. We don't really need that stuff. We just need location. As you can see, it goes 0, 0, 0, 1, 0, 2. And if I come back to my drawing here, that is exactly what, if I can't, why can't I scroll up? Right, here we go. Right, if I come back to my drawing here, it's 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Let me see if I can bring these closer together so that I can. Right. And as you can see, the numbers kind of line up, the objects line up to how they were pulled from the grid world. And hopefully at 2, 2, we see a skip here. So it's 2, 1, 2, 3, because 2, 2 would have been my detector critter. And then at that point it resumes, pulling every object, and the number of actors is 24, because the 25th actor is the detector critter. So hopefully that helps you. That'll help you create predator and prey. I think this is the harder part of predator and prey, and since we had a lot of, we had a code days, and you're going to lose a couple of days to work on this project, this should help you get through a lot of it. Okay. Hope you have a good rest of the day, and I will see all of you tomorrow.